Today we are going to be doing properties of segments in a circle. We have a test Wednesday, but not tomorrow, next Wednesday. So let's take a look at these notes. You have this on your desk. Okay. It says segments of circle notes. These are the rules dealing with chords, secants, and tangents in circles. So, intersecting chords. If two chords, go ahead and fill that in. If two chords intersect in a circle, the blank of the lengths of the segments of one chord blank the blank of the segments of the other. Now you can see it right here. Okay. Each chord, which is a segment inside a circle, when they cross, they make like an X shape, right? So, when they make that X shape, they have four parts. Now look at this. A times B. Okay, those are two parts of the same chord. And they what? What does this little dot mean right here? Multiply. That's called the product. The product of the lengths of the segments of one chord, and then right here, equal the product of the segments of the other chord. So all you're doing is multiplying the parts of one chord equals multiplying the parts of the other chord. Let's try an example. Okay, example 1. Here's a chord. What do I do with these two parts of the chord? Multiply. So let's do that. 3 times x equals, and on the other chord, 2 times 6. So 3 times x gives us 3x. 2 times 6 is 12. That's my last step. Divide by 3 and I get 4. 12 divided by 3 is 4. Let's try number 2. Alright, on number 2, I got these parts of the same chord multiply, so 6 times x equals, and then on this chord, 4 times 9. Alright, 6 times x is 6x, 4 times 9 is 36, and then last step, divide by 6, and I get just 6. So if you got two chords inside a circle, okay, those are going to multiply and set them equal. Seems doable. Not too bad. Alright, well, let's make it a little bit harder down here. For two secants, okay? So the two chords, not too bad. Two secants, okay? I really want you to pay attention because this can be confusing. A lot of people mess this up, okay? This says if two blank segments. These are called secant segments. You might remember secants are lines that go through a circle. These aren't lines because they have endpoints, so they're called secant segments. And they are drawn to a circle from an external point, right here, where they touch. The blank of the length of one secant segment and its external part. So again, we're doing multiplication. So it's the product. And it says it's equal to the, on the other side of the equation, it's also the product of the length of the other secant segment and its external part. Now, I don't want you to make the mistakes that everyone makes when we do these problems, so I want you to look closely. This says A times B, right? Now you tell me, looking at this little diagram, is A inside the circle, outside the circle, or the whole segment? What do you think? Okay, A is outside the circle. That's why they call it the external part, okay? So A is easy to tell, but here's where people mess up. Is everyone looking? B is inside, outside, or the whole thing? The whole thing. Most people get this wrong because they think B is the number on the inside. That would be wrong. again, I'm going to try to make this in our own words here. What you're multiplying is outside times the whole segment. The outside part of the segment times the whole segment. Okay, so if you get that mixed up, it'll mess you up. So I want you to get messed up. So let's look at this example. Okay, so let's start with the left side secant. Okay, first thing we need to figure out is what's on the outside. So you tell me what's on the outside of this secant. 3. That's not too hard. Here's where people mess up. Y'all ready? Y'all focused? Y'all gonna think about this? What is the whole thing? If you said 5, that was wrong. But if you said 8, because you added 5 plus 3, that's the whole thing. Does that make sense? The whole thing has to be 8, 5 plus 3, right? So the things you're going to multiply on one side of the equation is 3 times 8, okay? Right? So, what about the other side? So what is on the outside over here? 4. Now, check this out. Think about it. What is this whole thing? Not 4x. X plus 4. See, 4x is multiplying, but we are adding. Okay, so this is x plus 4. Okay, so what on that side, what do I multiply? The outside times the whole thing. Okay, so let's make our equation now. I'll start with the side with x. So I'm going to have 4 times x plus 4. Equals, outside is 3, whole thing is 8. The outside times the whole equals the outside times the whole. That's how the rule works, okay? Could we solve this ourselves? Y'all know PEMDAS, parentheses, let's distribute first. 4 times x is what? 4 times 4 is what? Okay, and then 3 times 8 is 24. So you could solve that two-step problem. What do I do with that 16? Minus 16. 4x equals 8. And then to get rid of that 4, what do? Divide. 8 divided by 4 is 2. All right. All right, so on to the next page. We're going to skip number 2 here. We're going to head on over to this next part of the notes, okay? Secant and tangent. If a blank segment and a blank segment. So it's in the title here. A secant segment and a tangent segment. You might see it in the picture. One of these is like what we just did, but A is a tangent, okay? So if you have those two, what you're going to do is, it says the blank of the length of the secant segment and its external part. This is once again the product, just like the last one we did. You're going to do the outside times the whole thing equals the blank of the length of the tangent, okay? So the A has nothing else to multiply with besides itself. So notice how it's A what? Squared. So it's the square of the length of the tangent segment, okay? So outside times the whole thing equals the tangent side squared. Let me show you what I mean by that. All right, on number 1. Look at the secant. What's outside here? 4. What's the whole thing? X plus 4. And then the tangent times itself is going to be 8 squared, right? So let's write that equation. We have outside, which is 4, times the whole thing, which is x plus 4, equal sign, and then 8 squared, because the tangent is going to be squared, right? Make sense? Outside times whole equals the tangent squared. Bless you. So let's distribute 4 times x, 4x, 4 times 4, 16, and equals, what's 8 squared? 64. And now, let's get rid of the loner, minus 16, minus 16. So 4x equal sign, 64 minus 16 is 48. And then to get rid of that 4, divide. 48 over 4 is 12. Alright. Makes sense? Ish. Ish. Alright, number 2. Outside is 2. What's the whole thing? Not 16, but 18, right? So we're going to do 2 times 18 equals the tangent times itself, or the tangent squared. 2 times 18 is 36. And to get rid of that square, what do we do? Square root. Square root of 36 is 6. That's it. All right. So what you want to do, you can separate the notes from the assignment. Let's see here. You don't have to do number 6. That's it. All right. So you can skip number 6, and you may begin. We're going to have a little bit of today, obviously, and then you'll have tomorrow to not only finish this, but work on other missing work that you want to work on. Yeah? Again, 2.5 weeks, getting your grade up. After that, oh well. All right, see you.